In this question, the circle shown in the diagram has as tangents the x-axis, the y-axis, the line x plus y equals 2, and the line x plus y equals 2k, where k is greater than 1. Now, since we've been told that the circle has tangents of the x-axis and the y-axis, that means that our x and y coordinate for the center will also be equal to the radius. So I'm going to call that r and r. Also then, that radius, you can see the red line here, and then the green line. So the perpendicular distance from our lines will also be equal to the radius. So for this, I'm going to use the perpendicular distance formula. So ax1 plus by1 plus c all over a squared plus b squared. Now, for the first one I'm going to use x plus y minus 2 equal to 0. And our point then is going to be r and r. So that'll be x1, y1. So let's put these values into the formula now. So a for x1, so a is going to be 1 times x1, so times r, plus b, y1, so that's going to be 1 times r, plus c, so minus 2, all over a squared, the square root of a squared plus b squared. It's going to be 1 squared plus 1 squared. And this now is going to equal the radius, so again is equal to r. Okay, simplifying this now, I'm going to have r plus r minus 2 all over root 2 is equal to r. So then 2r minus 2 is equal to root 2 r. Now let's bring the r's to one side, so I'm going to have 2r minus root 2r is equal to 2. Factorize out now r, so I'm going to have r, then bracket 2 minus root 2 equal to 2. So that means r is equal to 2 divided by 2 minus root 2. So you actually now can't leave it like this, so you have to rationalize the denominator. So you can't have a minus root 2 below as your denominator. So if you actually just put that straight into the calculator, so 2 over 2 minus root 2, that'll give us r is equal to 2 plus root 2. Okay, so that is going to be our radius now. So I'm going to do the exact same thing now, just with the other equation. So let's do that over here. So I'm going to have, again, ax1 plus by1, then plus c over a squared plus b squared. And now my line is going to be x plus y minus 2k, point r and r. So let's put in our values. So ax1 will be 1 times r, by1 again will be 1 times r, now minus 2k all over the square root of a squared plus b squared. So that will be 1 squared plus 1 squared. Now again equal to our radius. So working this out, we'll have 2r minus 2k over root 2 is equal to r. So then 2r minus 2k is equal to root 2 r. Now, so you can see now it's very similar to the previous one. So one thing I forgot to put in here is this modulus sign. So when solving with a modulus, okay, you'll always have a plus and a minus that you'll equal to. So I'm going to put now the radius back in. So I already found the radius as 2 plus root 2. So I'm just going to write that here. So radius is equal to 2 plus root 2. And again, I need to keep that modulus sign there. Okay, so let's put that in now. So I'm going to have 2 now times 2 plus root 2 minus 2k is equal to root 2 times 2 plus root 2. So expanding this out, I'm going to have 4 plus 2 root 2 minus 2k is equal to 2 root 2 plus 2. So now with the modulus sign, what I'm going to do is I'm going to do 4 plus 2 root 2 minus 2k is equal to 2 root 2 plus 2, as if I'm solving a normal equation. So doing that, I will have 4 minus 2 plus 2 root 2 minus 2 root 2 is equal to 2k. So these will cancel, so then I'm going to have 2 is equal to 2k. So that means 1 is equal to k. Now, that actually is the exact same as the first equation, which is x minus y minus 2. So it can't be that. So let's go back now to this part here. Okay, and what I'm going to do now is I'm going to do, so I'm just going to draw a line here to separate it. So I'm going to do 4 plus 2 root 2 minus 2k equals now minus 2 root 2 minus 2. So now I'm going to have, so let's sort this out. I'll have 4 plus 2 root 2 plus 2 root 2 equals then 2k. So now I have 6 plus 4 root 2 equal to 2k. Then divide by 2. So now I'm going to have 3 plus 2 root 2 is equal to k. And this now is my value for k. Okay, and that's the final answer then.